We're going to take a look at how to solve absolute value equations by looking at the absolute value function. Now remember that the definition of the absolute value can be written as a piecewise function, and that is f of x is equal to, and we're going to write curly brackets to represent the two pieces. The first piece has a positive slope of 1, so it's going to be x, and this occurs if x is greater or equal to 0. The second piece has a negative slope of -1, and that'll be x, and this occurs when the domain is x is less than 0. So from this definition, we can see that there are going to be two cases to consider. In the first case, the expression inside the absolute value symbol is going to be positive or 0. And we can see that because x is greater or equal to 0. The second case we're going to take a look at is when the expression inside the absolute value symbol is negative. And that is when x is less than 0. All right, so let's take a look at this first example. We have the absolute value of x plus 1 equal to 4. Now, we're going to take a look at case 1 and case 2. So case 1, and I'll put case 2 in a different color. All right, so case 1 is we're just going to solve it pretending that the x plus 1 is a positive value. So we're simply going to rewrite the equation again. So x plus 1 equals 4. And we solve. So here x is equal to 3. And then we check. And we're going to substitute 3 back into the original equation. So the absolute value of 3 plus 1 equals 4. And yes, indeed, the absolute value of 4 does equal 4. So this one is good. So x equals 3 is one of my answers. In the second case, we're going to pretend that the expression is now negative. So we're going to write this as negative, and then in brackets, x plus 1 equals to 4. Now, I can actually divide the negative to my right side, which I'm going to do. So now I have x plus 1 equals to -4. And then we have x equals -5. So let's check this answer. So we have -5 plus 1. And -5 plus 1 is -4 equal to 4. And the absolute value of -4, it is indeed positive 4. So 4 equals 4. And there is my second solution. Now, I like to show you graphically how this looks like so that you can see and convince yourself that there are actually two solutions. So what we're going to do is we're going to pretend, or I'm going to show you that y1 is going to equal the left side of the equation, and then we're going to show you that y2 will equal the right side. All right, so then we have two equations, and we're going to graph both. Now remember, if they equal the same y value, then they would be equal, which is how you get this equation in the first place. So I'm going to graph these independently. So the first one is the absolute value of x plus 1. So this has a vertex of -1. And when x is -1, we get 0. Okay, so we plot this. And then we know that the slope is 1, so we're going to get a whole bunch of points in this direction. And we have a straight line that goes this way. Now, because it's symmetrical, we now know that we also have points going in the other direction. Also with a slope of 1, but this time it's -1. Okay, so that is the absolute value of x plus 1. Now we're going to graph y2 equal to 4. So y2 equal to 4 is equal to a horizontal line and hitting the y-axis at 4. So that's going to look like this. So we can see that these two graphs intersect at these 2 points here, and those 2 points have an x value of -5 and 3, which matches my algebraic solution to the same equation. Let's take a look at another example. That way we can see how to use both case 1 and case 2. So we're going to solve this equation here. Let's just ignore the absolute value. So we get 3x plus 4 equal to 7x. So this is the case where the inside is positive, so we're just going to leave it alone. And here we get negative 4x is equal to negative 4. So x is equal to 1. So let's check. And always check your solutions to absolute value because sometimes they don't work. So here we get the absolute value of 7 equals 7. And yes, indeed, 7 does equal 7. So x equals 1 is one of my solutions. So now let's take a look at case 2 when the absolute value is negative. So we're going to place negative, and then we're going to place the expression in brackets. 3x plus 4, and that equals 7x. In this case, instead of dividing the negative, let's multiply it out on the left side. So I get negative 3x minus 4 equals to 7x. So negative 10x equals positive 4, and x equals negative 4/10, or negative 2/5. So let's check again. So plugging in negative 2/5, I get this. Now I can actually see something happening on my right side. So I know that on my left, I'm going to absolute value something. So no matter what I absolute, this left side will always be positive. Now notice that on my right side, I get negative 14 over 5. So this is impossible for me to take the absolute value of a number and get a negative value. So let me write this down to remind you. So let's take a look at another equation here. So again, we're going to take the positive absolute value. So we have x plus 4 equals x minus 1, and I subtract x from both sides, and I get something a little bit weird. I get 4 equals negative 1. So that's not true. So from the positive absolute value, we get no solution. So let's write no solution so we know that's the end of that case. Now let's take a look at the negative case. Okay, so we get negative x minus 4 equals x minus 1. Bring the x's to my left. I get negative 2x equals 3. And then x equals negative 3 over 2. So again, let's check. Okay, and then again, I see that on my right side, I have a negative number minusing a positive number, and we're going to get even a more negative number. We get negative 5/3. I don't actually have to figure that out, but I already know again that this left side is positive, and my right side is negative. So again, we can't get a negative value. So similar to this one that we just did, it has no solution for the second piece. Now this one also had no solution. So the solution for C is actually no solution for the entire equation.